This is the screencast for section 4.3, example 6. We're going to study quadrantal angles. Quadrantal angles are the angles whose terminal sides lie on any of the coordinate axes. That's why they call them quadrantal, because they happen in 4 different spots on the axes. So for example 6 here, find each of the following if it exists. If the value is undefined, write undefined. So you are actually going to see undefined here in the quadrantal angles, and I'll show you why. So we're going to start this off the same way we did the previous problems. We're going to graph, we'll put the angle negative 270 degrees on the coordinate plane in standard position. So negative 270 degrees is going to be, let's see, negative 180, right up here. Well, here's the problem. You're supposed to create a reference triangle by connecting the terminal ray and the x-axis with a perpendicular, but that perpendicular is smack on top of the terminal ray. So there's no triangle there. What am I supposed to do? Well, let's pick an easy point. Let's pick the point 0, 1. If I had a triangle, let's say this was just slightly a triangle, which it isn't, but let's just say it was. Its hypotenuse, these two legs are the same, 1 and 1. And this width right here, this x-coordinate, is 0. So it's kind of like a mini non-triangle, I guess. So if we're trying to find the sine of negative 270 degrees, you're looking at the opposite over hypotenuse, which would be 1 over 1. So your reference angle would be down here in the corner here. So it'd be opposite over hypotenuse, 1 over 1, so that would be 1. Now the tangent of 3 pi. Again, I'm going to put this on standard form. 3 pi would be pi, 2 pi, 3 pi, so a circle and a half. So I'm going to symbolize that with my little swirly angle marks there. So I've got 3 pi, and I'm looking for the tangent. Well, if I'm supposed to connect the terminal ray with the x-axis using a perpendicular, there's no real... I can't do it. There's no distance here because the x-axis and the terminal ray are the same thing. So I'm going to pretend like there's this tiny little triangle there. Tiny little triangle, which really isn't a triangle. I'm going to use this reference angle, and I'm going to pick an easy point. Maybe negative 1, 0. Negative 1, 0, a point on that terminal ray. So that means, let's see, the x-coordinate would be negative 1, the hypotenuse is always positive 1, and then the opposite here would be 0. This height of that little non-triangle is 0. That's why it's a non-triangle. So if I take the tangent of 3 pi, I'm using the opposite over adjacent, so that would be 0 over negative 1, which is 0. Part C asks for the secant of 11 pi over 2. Are you kidding? 11 pi over 2? Okay, so that's 5.5 pi. So that's, all right, here's my initial ray. So I've got, let's see, 2 halves, 4 halves, 6 halves, 8 halves, 10 halves, 11 halves would be down here. Unbelievable. Okay, so there's where my terminal ray is. I'm going to pick an easy point on that terminal ray, so 0, negative 1, and I'm going to make a little mini reference triangle out of that. So again, I'm going to pretend that this terminal ray is slightly off. I'm going to pretend that that terminal ray is not quite on the x-axis. So then my reference angle is going to look like that. The right angle perpendicular to the x-axis is going to be right there. So this would be the x-axis. Now I'm just going to make up these dimensions because some of them don't exist. This width right here is actually 0 because remember, this is supposed to be a completely smushed triangle. The opposite side is going to be negative 1 because that y-coordinate is negative, and then the hypotenuse is always positive, so that's going to be positive 1. So if I look at the secant of 11 pi over 2, let's see, secant is the reciprocal of cosine, so that would be hypotenuse over adjacent. So the hypotenuse is 1 over the adjacent is 0. 1 over 0. Oh, look, there you go. There's your very first undefined. Congratulations. All right, let's go look at the now try problem. Number 41 asks for A, the sine, B, the cosine, and C, the tangent for the given quadrantal angle. So let's plot that in standard form first. Here's our initial ray. And then, okay, negative 7 halves pi. So here's 2 halves, or a whole pi, 4 halves, and then not 8 halves, so 7 halves. So that's going to be down here. So we have a very similar triangle like we did last time. I'm going to pick an easy point, so that would be 0, negative 1. And I'm going to pretend like this is not quite on the y-axis. Now this width here is 0. This y-coordinate here is negative 1. And then the hypotenuse is positive 1. So to find the A sine of theta, that's going to be, let's see, opposite over hypotenuse, so negative 1. The B cosine of theta will be adjacent over hypotenuse, so that's going to be 0. And C tangent of theta is going to be opposite over adjacent. So, oh, that's negative 1 over 0, undefined.